In this lesson, we are going to be working with similar solids and solving problems using proportions. In this first example, we have two similar prisms, and we are looking for the volume of the smaller one. Now, we only know one of the dimensions in the smaller one, so we're going to have to use the help of the larger prism. To find the volume of the larger prism, we are going to multiply the area of the base by the height of the prism. So the volume equals 71.442 cubic centimeters. For the smaller prism, all we know is the height. So let's compare the height of the smaller prism to the height of the larger prism. The heights are in a ratio of 2.1 to 6.3. Which means that they're in a ratio of 1 to 3. The dimensions of the smaller prism are 3 times shorter than the dimensions of the larger prism. This scale factor is not the ratio of the volumes, though. We have to cube this ratio to get the ratio of the volume. So with a side ratio of 1 to 3, we end up with a volume ratio of 1 to 27. Let's write a proportion now to help us figure out our missing volume. Notice the x is in the numerator here, and that's because the missing volume is the volume of the smaller prism. So we need to make sure that we get our x in the right location. One way to solve proportions is by cross-multiplying. So if the volume of the larger prism is 71.442 cubic centimeters, then the volume of the smaller prism is 2.646 cubic centimeters, because the volume of the smaller prism was 27 times smaller than the volume of the larger prism. Here we're told that we have similar prisms again, and this time the ratio of A to B is 5 to 2, and that's a side ratio. We're told the volume of the large prism is 250 cubic centimeters, and we're looking for the volume of the smaller prism. We can use the side ratio to help us find the missing volume, but first we have to cube it. So we have a volume ratio of 125 to 8. Now we can use a proportion to help us figure out the missing volume. And we end up with a volume of the smaller prism of 16 cubic centimeters. For this example, we have similar cylinders, but this time we know both volumes, and we're missing the radius of the larger cylinder. So we're going to have to work backwards on this one. Since we know the volumes, let's begin with the volume ratio. We know that the volume ratio is the cube of the side ratio, so we're going to need to uncube the volume ratio. We call that the cube root. So the cube root of 8 to 1 equals 2 to 1, and that is now our side ratio, or in this case, the radius ratio. Now we can use a proportion to figure out the missing radius. So the radius of the larger cylinder, it must be 20 centimeters. For our last example, let's look at one that involves both volume and area. A rectangular prism aquarium holds 64 gallons of water. A similarly shaped aquarium holds 8 gallons of water. If a 1.5 square foot cover fits on the smaller tank, what is the area of a cover that will fit on the larger tank? So 64 gallons, that is a volume. And the 8 gallons, that's the volume of the smaller aquarium. So let's write the volume ratio. This volume ratio just tells us that the volume of the larger rectangle is 8 times larger than the volume of the smaller rectangle. Now the question involves a missing area, because we're wondering about the area of the cover. Now we can't go directly from the volume ratio to the area ratio. So what we're going to do is go from the volume ratio to the side ratio, and then from there we'll go to the area ratio. So we're going to uncube the volume ratio to get the side ratio. And then we're going to take the side ratio and square it to get the area ratio. So according to our area ratio, the cover on the larger tank will be 4 times larger than the cover on the smaller tank. Let's write a proportion to figure out the area of the cover that will fit on the larger tank. So the larger tank requires a cover with an area of 6 square feet. Hope these examples have been helpful. Signing off.